topic we're talking about is called linear equations. Okay, so let's break that down a little bit. Let's start with the equation part of it. Firstly, before year 10, you would have probably learnt there are things in, so we're talking about algebra here. You would have learnt there are things called expressions and things called equations. And an example of each, an expression might look something like this, x plus 7. An equation, on the other hand, might look like this, x plus 7 equals 8. So, can we think back to a previous year level, and would someone like to tell me what they think the difference between an expression, an algebraic expression and an algebraic equation might be? Yes? One gives you the answer, one doesn't. Absolutely correct. What is it about the one that gives you the answer? Which one does give you the answer? Equations. And what is it about the equation that will allow you to give you an answer?
Gives you equals and then number equals.
Great. So the easiest way to identify it is that the equation will generally contain an equal sign, whereas an expression doesn't. So that expression, really, we don't know enough to be able to do anything with that expression unless you're told what x is. The variable x. If x is 0, 0 plus 7 would be 7. If x was 1, 1 plus 7 would be 8. If x was 2, 2 plus 7 would be 9, and so on and so forth. There is an unlimited amount of answers that this can be depending on what x is. You need more information before you can do anything with the expression. Whereas with the equation over here, whoops, better press the button. With the equation over here, with the equal sign, there is only one value of x that makes that true. And that value would be, if x plus 7 equals 8, what do you think x must be for that to be true? It can only be one thing. The answer is 1. 1 plus 7 equals 8. Yep. If I said, can x be 3 here, I hope you'd say, well, 3 plus 7 equals 10. That's not 8, that's not true. X can't be 3. So when we're talking about equations, we are talking about algebraic sentences, for want of a better word, where we can actually solve it for x. That's what makes it an equation. So how do we go about solving linear equations? We are going to learn a series of steps in order to solve a linear equation. And what we do is we solve our equations by what we call inverse operations. Inverse operations. And I'll explain that in a second. And essentially what it means is, at the moment I've got this mathematical equation, x plus 11 equals 0. Ultimately, I want to know what x is. So if I say, what is x? My final answer is going to be x equals something. A box there. So in order to get from here to here, what you need to do is you need to strip away from the x anything else that's there. At the moment down here at the answer, we've got x all by itself on the left-hand side, and we'll have an answer on the right-hand side. The original equation doesn't have x all by itself. It has a plus 11 there. So what we need to do is we need to get from up here to down here, and we do it by what's called inverse operations. The items that are next to the x that we don't want anymore. So in this case, I've got a plus 11. What is the opposite of plus 11?
Minus 11.
Minus 11 is correct. So I'm going to minus 11 from there. So if I've got plus 11 minus 11, it's gone. 11 minus 11, gone, 0. But will my equation be in balance if I do this? Can I just take 11 away from one side of my equation and expect it still to mean the same thing? No, if you think of it like a scales, if I minus 11 from one side, that side is now lighter and my scales are going to tip. So I need to keep my equation in balance, which means I need to do exactly the same thing to the other side. So you'll hear me say a lot as we go through this stuff, what you do to one side, you do to the other. It's like the golden rule of solving equations. So if I do this, x plus 11 minus 11, and then I'm minus 11 on the other side, x plus 11 minus 11 gives me the x that I want. 0 minus 11 gives me minus 11. In this occasion, I have solved my equation in one step. X equals minus 11. And I've done it using this idea of inverse operations. Now, usually at this point, when we go through this sort of thing, there'll be one student, probably more, sitting there going, why have you gone to all that trouble, Mr. Coldwell? It's obvious that the answer must have been minus 11, because that's, minus 11 plus 11 equals 0. I can see that straight away without having to do any of that stuff you were talking about before. If that's you, thinking that at the moment, you're not wrong. That's exactly right. You can see, using just logic and good mathematical thinking, yeah, 11 must indeed be minus 11 for this to be true. But what we're doing is we're starting with quite a simple equation. We're learning these techniques bit by bit and building on that. So when you have an equation that's much more complicated, where you can't just see the answer straight away, we've got these steps and tools available to us to step by step get to our answer. Okay, let's look at this next example here. Next example, we've got 5x plus 35 equals 0. So already it's starting to get a little bit harder just to work out what x is in our heads just by looking at it. So if we use these inverse operations, we can step by step get to the answer that we want. Let's think of it this way. Our final answer needs to be x equals and some number. I'll leave a green box to indicate that that's our final answer. Is going to be x equals some number in the green box. In order to get that, we use inverse operations, because if we look at our original equation up here, we have a 35 on the left-hand side. We don't want that anymore. We also have that 5. So the first thing we need to do is make sure we understand what the equation is actually saying. 5x means 5 times x. Then we are adding 35, and the answer equals 0. So we need to get rid of that 5. We also need to get rid of that 35, but we need to do it in the correct order. So that's where what I was saying before, this idea of SAMDEB, which isn't an official mathematical term, it's just, I think, a good way of thinking about it. We're doing BEDMAS in reverse to decide, do we get rid of the 35 first, or do we get rid of the timesing by 5? So if I go through this, it says I would get rid of the addition before I would get rid of the multiplication. Okay? So that suggests to me, that I need to get rid of this plus 35 before I get rid of the divide by 5. So what is the opposite of plus 35? Take 35, thank you very much. So if I take 35 from there, what I do to one side, I do to the other. And then my next step, if I work down this way, I'll have 5x equals minus 35. Okay? So the 35 minus 35 is 0. The 0 minus 35 is minus 35. Okay, I'm getting closer to what I want. Now I only have this 5x on the left-hand side. That's 5 times x. What's the opposite of timesing by x? Divide by 5. What's the opposite of timesing by 5? Divide by 5, sorry. So I divide that by 5. What I do to one side, I do to the other. 5x divided by 5, as was said before, the 5 divided by 5 equals 1. 5 divided by 5 is 1, 1x. That's what we want. 30 minus 35 divided by 5 is minus 7, and we have got our final answer. In here, we've got 13 plus 7x equals minus 1. This might throw people a little bit, because all of a sudden we're used to seeing the 7x first and then the number after that. So one thing that's worth thinking about, and I really would listen to this because it's pretty handy advice, when you have a number like, in this case, you've got 13 and you've got no sign before it. If it was negative 13, there would definitely be a negative there, wouldn't it? So if it isn't, if you clearly don't see a negative sign, that's basically plus 13. We don't write the plus 13. If the number's the first thing in the equation, we don't write the plus there. But if we had to put a sign, it would be plus 13, wouldn't it? Because if it was negative 13, we definitely would have the sign written there. Is that cool? Now, one thing that you can actually do with mathematical expressions or equations is if you take the whole thing, including this, so anything that's separated by pluses or minuses, so I've put boxes around it to indicate any of the items, any of the terms in our equation that are separated by pluses or minuses, I can put the boxes around them like I've done, and I can actually pick up those boxes and move them around. So I could grab that whole plus 7x and move that out to the front, and then I could put the plus 13 after it. There's nothing wrong with that. As long as you're taking the sign that's in front of it with the, as you move them around, I could write that as 7x plus 13 equals minus 1. And then I could solve it using my inverse operations. I'm going to minus 13 from both sides first, giving me 7x equals minus 1 minus 13 is minus 14. Divide both sides by 7. X equals negative 2. But I didn't need to do that. I could have answered it without moving it around. I would have still got the same answer. I just thought it was worth mentioning. If I started with the same question again, there's no reason why I can't just leave it the way it is. And if I remember my inverse operations order I have to do, I have to get rid of that positive 13 before I get rid of that timesing by 7. So I could just go minus 13 from both sides, and that ends up 7x equals minus 14, which is exactly the same spot as we're already at. Okay?